Hi, thank you for joining me today for Tradecraft development in Adversary simulations. My name is Fatih Ozavci. Also, thanks Adversary Village and DEFCON for hosting me today. Today we will talk about Tradecraft development, and we will have different chapters that we will introduce how Tradecraft works, as well as how the other implementations can be used. After that, we will talk about how we can develop our own implementations. Chapter 1b will introduce the development environment to you, and Chapter 2 will help you to build your own C2 as well as implant. Chapter 3 will enrich your implant using Windows APIs and some other functionalities, and Chapter 4 will actually improve your implant for the evasion perspective. So you can make your implant invisible as much as you like. Today, the objective is developing an implant from basic to advanced skills. It's up to you how you can enrich them. My name is Fatih Ozavci. I'm Managing Security Consultant in the Messeglink, Australia. Actually, I love adversary simulations and security research. Therefore, I had several different tools developed for these purposes. I have also presented those tools and my research in Black Hat USA, Europe, DEFCON, and other security conferences. I currently also study Master of Cybersecurity in University of New South Wales. So you will use some of those tools today as well. Let's talk about those tools. I have developed TA505 Plus Adversary Simulation Pack. That is a full simulation pack that comes with some repurposed tools, new tools, as well as some additional evasions and bypasses. It has 4+ hours of video to prepare each stage for you, as well as an implementation guide. And in the end, there is also a large report that explains how this tool and environment will work for you, and it can be actually useful for you to build your own exercise. I also developed Patak C2 1.5 years ago, and the reason behind of it was I needed to automate some of the red team actions. Probably it is also same for you. So you need your own C2, you need your own implant, and you need to make things automated for the blue team exercises for this work. In addition, I have also tested malware generator. I assume that some of the attendees and participants here are actually coming from the blue team, sometimes even data analytics. That's why sometimes you need friendly tools to generate this type of traffics, and Tesat Malware Generator is a response for this one. But it can be also used for your own Tradecraft development because it comes with Blazor UI, web interface, and different types of protocols and services. So you can enrich them and make them actually working with your implant, and maybe it will be useful for you. It's up to you. Finally, I have also weaponizing C# training. That is also available in GitHub repositories. So you can just clone it and you can start working on it to understand how C# can be weaponized for the purple team as well as red team exercises. I am not a developer. I develop those tools for fun as well as for simulations. So if you want to start exercises today, you need to actually clone a GitHub repository. That is the address of the GitHub repository. So you can use git clone to get this repository, compile the tools and work on them. It comes with code examples, also the presentation itself. In addition, it has a C2 capabilities. For example, there's a text file there. There's actually a C# file, an executable. So you can actually use these functionalities while building your C2 implant, and you can use them as a kind of instruction list. So feel free to participate where when necessary or you feel comfortable. I will talk about threats and simulations firstly. We have different levels, different colors of the adversary simulations. Red team is the most interesting one because we actually start with zero information, we need no collaboration, and we try to infiltrate the organization just like a threat actor. In the purple team exercises, we actually collaborate. In this case, the color changes. The meaning is actually the blue team joins us. Blue team can be actually threat intelligence or security operations center or some actually interesting instant response teams or some other reverse engineering teams as well. And offensive teams will be also red team or penetration testing or maybe more than that. There's also automated tools that can be used for breach and attack simulations. And they are useful to actually ring some bells on the environments to understand that your coverage is correct, or your network is in scope, or your endpoints are in scope. So different types of colors actually come with different abilities. So it's up to you how to colorize them based on your purposes. This is an example trade intelligence actually information extracted from Microsoft Trade Intelligence reports. It is about Nobelium and how they operated their actually campaign. During this campaign, they compromised SolarWinds, then they compromised some of the vendors, and after that some government organizations. So you can extract this type of information from the trade intelligence reports. This is a basic example, so you can visit this link in Microsoft Trade Intelligence repository, and you can start working on it. This is important because while we are building the adversary simulations, we use this type of information. So if you look at them in a different way, you can also reuse them. For example, this one is a simple attack and C2 communication type of SolariGate. And you can see that it can target the organization. If organization is in the target list, it can start at second stage, and then third stage, and fourth and fifth, whatever necessary. But it actually works on different C2 types. Sometimes it is DNS, sometimes it is web, sometimes social media. In this Nobelium case, it started with the DNS, and then it also loaded Cobalt Strike as well. So we can see this information in the Trade Intelligence report, so we can actually customize our simulation based on this information. When we read it carefully, we can also see that there can be some additional campaigns as well. This one is another example from Nobelium, but this time they have sent an email, and after this email, they started actually a JavaScript file and a HTML smuggling feature. They actually downloaded an ISO, and this ISO is mounted, and then the code executed. Actually, ISO has been actually decoded. So simply it writes the ISO to disk. So it's up to you how you can implement this. You can use the JavaScript to download the ISO, or you can just encode base64, encode this ISO file and just decode this on the fly. And you can make it an HTA file or HTML file or whatever you are comfortable with. So simply you need to make it working. But the intelligence report already gives you some information. For example, the ISO content or how this LNK file, link file works. So you can see the commands and parameters there. Moreover, the script content and some additional information can be also used to develop this type of tradecraft. Finally, you are not alone. There are other specialists actually working on this type of stuff. For example, creating a kind of simulation like that, it needs some steps. First of all, working on a JavaScript, making it to be able to decode base64 file, and start actually building an ISO file and encode this for base64, and then embed this to the JavaScript to make it running. The thing is, it is slightly easier if you work on just one single exercise. But if you try to automate this, there will be some difficulties because of the compatibility requirements. For example, Jorge Orchiles has provided actually example for this exercise on Atomic Red Team. So feel free to visit this and it can be useful. Also, Mehmet Argene is actually a blue teamer. So he also developed some of the content, the adversary simulation initial payload part. So it can be also useful for you. Finally, Adam Chester also worked on some C# DLL export types and how it can be exported. It can be useful because we develop our Tradecraft today using the C# and .NET environment, but they are actually not unmanaged DLLs. So they have no exports. So if you want to export the functions and actually the content you use in this .NET assembly, you need to actually make your executable supporting them in the export section. So you need to add them one by one to the exports. You can do this manually or you can use some additional tools. That's why this blog will help you to understand how this process works. Another one is actually TA505+. I actually will explain how this adversary simulation environment works for you, because this is end-to-end example. The previous ones were only working on the initial payload preparation. The initial payload is there. For example, starting with an email, the email content could be HTML, and that HTML file or HTA file itself will have JavaScript that can get the code execution, and the JavaScript content will actually put the file on disk and we can make it running. Or sometimes we can use LOL beans for this initial payload as well. But after that, things get complicated. We need a command and control server. We need some security bypasses. We need a UAC bypass. We need MC bypass. We need sometimes ransomware examples as well. To do that, we need to prepare an adversary simulation pack from beginning to end. TA505 Plus is a response for this because TA505 was a trade actor, actually currently is a trade actor, but during those days, they were also targeting Australian financial institutions. So I worked on them and I made it a kind of exercise, but I didn't use exactly what they had in the campaign reports. My assumption was TA505 could improve and upgrade their abilities. This simply says that, yes, they can upgrade, and we don't know. Let's make it known. That's why I started working on Windows 10 up-to-date, Office 2019 up-to-date, as well as Windows Defender and MC full up-to-date system. So I decided that, what if the system, the target will be like that? How TA505 can improve their systems as well as the campaigns. That's why this adversary simulation pack is coming with a plus. And this adversary simulation pack has a full kill chain. That's why the kill chain has different stages coming with different tools for us to simulate them accurately. As there is no actually reconnaissance phase for this one, I prepared threat intelligence information there, so the video and the content is based on threat intelligence. But the rest of the phases, pretty much like a threat actor. So you only work on the weaponization, you also work on the delivery, and when you compromise this, you actually install the malware there for persistency. You also you also work on your own C2, and you try to complete some of the objectives that include also ransomwaring. So ransomware is a kind of known behavior of TA505. That's why I developed a simple tool to simulate those features. Those are the tools I developed or repurposed for the TA505 Plus exercise. So it can be useful for you to build. For example, Patak Dropper is the initial payload starter. When it believes that the environment is safe for it, it actually downloads the Patak MC bypass to patch MC, make it way more clean and to work, and then it downloads the Patak implant and go on. Patak service is the C2 service, and MC patcher is the MC actually bypass utility, and it is coming from Daniel Duggan's actually example, but I repurposed it to avoid detections. And also this dropper, the Patak dropper, can start with an Excel file because the TA505 was actively using Excel file. I use Excel anti-donut for it. So there are some tools and there are some new tools in this bucket. So how they work is just like this. The Excel file, and Patak dropper gets the MC bypass tool. When everything is clean, it loads the implant and establishes a C2 communications using the web sockets. Through this one, we have a real-time communication. All this path was undirected those days. Now it is directed. Of course, the tools, techniques, and the pack were public. So there were some signatures generated for it. However, everything is open source, so you can just repurpose those tools to do the same thing. For example, I have repurposed Daniel Duggan's MC patcher, MC bypass, to make it running again. And there's a video for it. So that will be your starting point. And you can use another way to actually customize this and start using again. When the exercise starts, we actually establish a ground between the implant and C2. However, we have objectives to work on, and those objectives are not always on the endpoint. There are some servers in the back, there will be some cloud services, and we need to connect those services, those systems to actually achieve our objectives. Through this path, I need to implement some additional features for my implant. That's why Patak C2 comes with implant-to-implant linking and some additional features for lateral movement as well. Through this way, I have demonstrated how we can compromise the servers using the lateral movement techniques as well as implant-to-implant linking techniques. In addition, I safely executed MetaOperator in memory and actually used MetaOperator for remote exploitation in this case. And MetaOperator was also using Metasploit as C2. I haven't used Cobalt Strike C2 in this picture. However, it is widely used by TA505. Patak C2, while mentioning like that, is a good C2 for me because I have actually implemented some of the essential features and it helped me to customize them. It avoided directions, it also comes with some abilities as well. Normally, it should be a kind of problem. More specifically, whenever you compromise a system, you try to understand who you are, what you do, and you use Windows commands. Instead, Fatih actually accepts the C# commands. So direct C# commands would work. It compiles in memory and runs them. For example, console write line the username. It writes the username, and you don't need to use who am I, for example. That's why Fatih comes with some additional abilities for me. And today I will talk about Fatih and the other features, but in this time I will assist you to develop your own C2 and your own implant. And Fatih is coming in MIT license. So simply you can repurpose anything and you can reuse anything. That means they are actually gadgets for you for today. And I actually supplied them in chapter 2 and 3 folders. So you can start enriching your implant using those abilities extracted from Fatih. And Fatih has lots of different gadgets like that can be used. Lateral movement or implant-implant linking, different types of protocols, SMB name pipe, TCP, UDP, WebSockets, they are all there. What you need to do is only merging them, combining them, and making yours. Fatih supports all of these features as the baseline. For example, .NET assembly features or shellcode injection features or some essential features such as upload, download, or linking another implant. So these type of things are implemented. And as mentioned, this is not a product. This was a proof of concept for me, and it can be a proof of concept as well. In this case, we have also some additional requirements. Sometimes it is a user interface, a graphical user interface. Fatih runs on command console, which is not nice. That's why I also developed TASAT malware generator. TASAT helps us to actually simulate some of the malware traffic using the protocols HTTP, WebSocket, TCP, UDP. Those are the current capabilities, and the DNS, ICMP, and some additional features will be added soon as well. I mention it here for another reason. Probably you also need graphical user interface for your C2 to make it shinier and look like a kind of a good product. In this case, you can repurpose TASAT as well. It is also MIT licensed, and you can actually use the Blazor UI for the interface, and you can still use your .NET environment. So it comes as another free tool. These are actually real-life deals. We generally try to simulate our exercises on cloud or on-premise servers, endpoints, and actually some of the remote locations. That's why we need to support lots of different protocols and communications. If you want to simulate them with no hostile capability, TASAT will work for you. If you are looking for also some additional hostile capabilities such as code execution or command execution or shellcode injection, yes, you need to improve your implant. These are also screenshots of how TASAT works. Now, we talk about some development fundamentals as well. C# is our preferred language for this workshop. We will talk about C# and .NET, but also .NET comes with different versions. We need to understand its basics first, because .NET doesn't have one single version that works everywhere universally. We use C# tools to develop custom abilities for us. This is quite helpful for the adversary simulations because we try to avoid deductions. We actually prefer deductions where they are necessary or where we need them. If they are not needed, we don't need to be detected. That's why our tools must be subtle as much as possible. C# tools actually started developing after PowerShell because PowerShell got secured by Microsoft using a couple of different ways, and that's why those restrictions moved all security researchers to C#. However, C# comes with additional problems. For example, different versions on Windows, Linux, and actually Mac. Also .NET Framework and .NET Core. There's no universal language. Also, Windows comes with different versions. For example, Windows 7 comes with .NET 3.5 and Windows 10 comes with .NET 4. So we need to understand these parts. Moreover, there's a problem with C# and .NET Assembly. Just like the PowerShell and what happened to PowerShell, C# also and .NET also gets their own security controls. After 4.8, .NET Framework also has MC integration, and Windows Defender can identify your malicious behaviors even though they are not running. While you are loading the tools or certain functionalities, they can be detected. So it's not only about static analysis evasion or some dynamic analysis evasion. It's more like someone is on your shoulder and watching what exactly you are doing. So this type of abilities and limitations must be known, because we can still leverage those abilities. We can still work with implants. We can still work with tools if we are actually aware of the Defender or MC or another EDR watching us, so we can just deal with them. .NET comes with actually CLR, and we need this runtime to actually interpret our binaries, the assemblies, but they are .NET assemblies, not native assemblies. To do that, we need to understand what type of runtime environment we have. If you are running on Windows, you can go to actually see Windows Microsoft .NET Framework, and after that the version folder. Then you can see the versions, whatever they are. They may be .NET 2, .NET 3.5, or .NET 4. Some of the functionalities are missing in .NET 2 or .NET 3.5. That's why your implant must work on all of them actually universally. And another problem there is, it depends on how you compile them. Let's start with some basics before making things complicated. How you can compile these operations as well as C# binaries are quite simple actually. You need Mono, and you can install Mono using apt install Mono complete on Linux, or for Mac you can just download this or use brew install Mono. Mono would help you to compile all these binaries with no hassle. But there is also .NET, and .NET is available for Windows, Linux, and Mac as well, and you can also download .NET. .NET can build, run, and work with nuggets as well, and Mono can do that. Mono can do this only for .NET Framework, while .NET can do this for .NET Core. That means our implant must be using .NET Framework to work on Windows 7 and 10 without any issue. And our server side could be .NET Core, which is cross-platform. And it comes with additional features, especially .NET 5, which is another type of core, the newer version. .NET 5 comes with additional functionalities that could really help us to automate some of the features and implement them easily. That's why we will try to develop our server side using .NET maybe 3.1 or .NET 5, and the client and implementation based on .NET Framework, which is probably between 4 as well as 4.8. Now, this is a simple hello. We need to use our namespace, we need to use a class, which is program in this case, and then we need to use a functionality here. Actually, this class and the function will turn to a type and method when we compile them on .NET Assembly. So it is quite useful and it is quite easy to customize them. For example, the console write line is there, and I can use, for example, system.console.writeLine. It is there, but if I have lots of console write line lines and instructions, I prefer using system in top. So simply, system will help me to use console directly with no hassle. So it is making things easier for the namespace wise. This is another example. This is for string operations. String operations of .NET is also quite familiar. If you previously developed some tools using a scripting language such as Python, you can see some of the string operations are quite easy to understand. Adding strings to other strings and modifying them, getting indexes, getting them maybe replaced or split, they work well. However, if you are dealing with the .NET Framework, not .NET Core, you may have limitations. That's why we use actually system text regular expressions. That's why we use regex.split and then the string and what could be split, or how we can replace. Because if we use string.replace or string.split, it will not work on .NET Framework because of the limitations. It depends on the version, of course, but most of the time it is not implemented. Therefore, while you are developing your implant, please make sure that it works everywhere. This is another example of if condition. If you previously coded on another scripting language, This may help you to understand how this coding works and how the conditioning, the branching works. In this case, I simply used arguments, and if there is no argument, the length is 0, it will say that what you want to do. But if there is an argument, it simply says that yes, these are my arguments, these are my parameters to run. It may help you to build your implant for the console-wise. But if it is not the only way to create branches, switch is also quite useful, especially for the menu generation. If you want to create a menu for your console application, switch will help you to create a kind of decision tree. It is same for the implant as well. Just imagine that the arguments coming are not coming from the arguments. They are coming from the WebSocket or a web page or a social media text. So you can see that they are coming there, so you can create your own branch. For example, the instruction is write, otherwise read. So you can actually create your own instructions there. Try to keep the switch simple as well as short, because you will need also the functions to handle things. For example, the write here is using console write line, but read is using the test function. The test function is important because it gives you another opportunity to continue in that branch. If you will implement everything under the switch and case, that will be a problem for you and the structure will be unmanageable. Instead, all your operations should be standalone functions in the same class or another class, and you can refer them under the case, under this conditioning. If the condition matches, such as the text is read, that function will be called. This type of structure would help you to build actually implant capabilities. For example, write, delete, read, run this, run that, and maybe exit as well. Loops are pretty similar to the other languages as well, and they can be implemented using for or while or for each. For each is useful for the objects, and it can actually get the objects, maybe the items of array or list or dictionary, and start working on them. But while and for, they are looking for a condition. For example, increase this integer 1 by 1 until the condition arrives. Or while condition is true, do all of this in a loop. These type of loops are useful when we are waiting or processing the objects. If there is a kind of dictionary or a list to process, we can use this type of for each approach or for approach, whatever useful. Another thing is we also have issues. As a starter, we fail, and fail is a good way to learn as well. But we need to also catch those failures. And they are called exceptions in the programming, and that's why we use try and catch. And this is a simple try and catch example. And it may help us to understand how we can fail or how we can proceed. Now, I also mentioned that you can use MCS or CSC to compile, right? But compiling them will make them executable, the PE binary. But there are other ways to run them. I will give you only the PowerShell starters now, but there are several. For example, the PowerShell can load a .NET assembly and can use system reflection assembly to load it and to run it. So it can actually get the types, get the method, and invoke it. It can actually focus on entry point as well. So they can be used to actually load the implant from remote. Let's collect everything together. We have an implant that can actually accept some of the parameters. The parameters can be coming from, let's say, console or a web page. And we can branch it using switch or if. When the condition arrives, when the instruction arrives, we can create our function and we can work on it. If implant works just like that, we need a starter. That's why we use PowerShell. And it can be called as a dropper as well. And what we do is simply downloading the DLL from remote and, for example, using system reflection to run it. Or we can download the source code, the CS file, and we can use add type and required assemblies if there is, and then run it. Revealing your C# code would not be great, but if it is just only a dropper just like this, If it is sacrificable, just sacrifice it and go on. Because it's a trade-off. You need to make it running. Then you can load your actually important code when things are safe. Now, it is exercise time. I will give you some hints to make it your own exercise time. As this is a pre-recorded workshop, I will only give you the hints, but meanwhile you will work on the exercises. So let's work on first a couple of things. You need to set up an environment. You can use Mono or .NET. Installing .NET is simple. Download .NET from Microsoft web page for your operating system and install it. Or you can use apt install Mono complete. And Mono comes with actually MCS and CSC that can be used to compile .NET C# code. Compile the sample binary in your chapter 1. You can use hello as an example as well. But there are also interactive menus. So try to make an interactive menu that can use a sample function for you, which is also given, and make your implant running on the console first. Compile it using Mono or .NET and run it. I will provide just a kind of starter now. This is a simple starter. Your chapter 1 comes with some examples, right? Condition, console parameters, and hello. The hello is simple. As I actually previously shown, it is simply writing a text using console write line. You can use MCS to compile this, and /out will give you the file name, and you can just name it whatever you want to do. It will be your output. And Mono can be used to run this executable. But remember one thing here, Mono is necessary. The executable won't work without the runtime. In .NET, it is slightly different. You can use .NET to compile things as well, but you need to use .NET new and then console application and your directory, actually the application name. And now I enter the application directory and it comes with a CS proj file as well as program CS. Program CS is similar again. Hello world. It's the same. But this time, .NET needs CS proj that gives .NET the instructions and the capabilities to run. So simply, when you hit .NET run, it loads if there is any references necessary in the CS proj and then runs it. Now it's your turn to enrich this using the other examples. For example, using interactive menu and the case switches. So this is the end of our first chapter. Thank you and stay tuned. We will focus on the chapter 2, chapter 3 and chapter 4 and how we can actually start building our C2 implant. If you have any questions, I will be available on Discord channel of Adversary Village. Thank you for listening this chapter 1. Hi, welcome to chapter 2. I hope you completed your exercises and your environment is ready to go. Now we will talk about how to develop an implant and a C2. So, we have micro-attack techniques, and they are everywhere in the threat intelligence reports, the offensive tools, defensive tools. What we need to do is focusing on what we can do with them. Therefore, we need to understand what IDs and what features to be simulated, and we can add them one by one to our implant as integrated or as a standalone binary or standalone feature that can run together. So let's start with how we should design our implant. Our implant may have some various features and they can be used for attack simulation. And those features could be built in or they can work from remote sources. We have some essentials such as upload, download functionalities or maybe some certain commands to run whatever we need constantly. But there must be also some features, capabilities focusing on the third-party tools. They could be .NET applications, PowerShell scripts, shellcodes, and some other features as well. We don't know. We will just develop our implant on demand. Whenever we need some micro-attack techniques, we will add those features using different capabilities. Even you can implement beacon object file, both process as well. If you want to add both process or both interpretation, you need to add some additional layers. Let's focus on these baselines and how we can develop our implant to support a .NET assembly, .NET source code, maybe PowerShell code, and also shell code itself using different types of injections. Moreover, we need also lateral movement. This means we need to also focus on some of the networking facts as well. That's why lateral movement compromise and maybe implant-to-implant linking will be necessary. Our implant will need to get multiple stages and instructions from web. So there are some different types of C2s. The first C2 type is just discovering things. It's more like non-interactive C2, and it will help you to identify the target, whether the target is in scope or not, such as the solar gate exercise. It may help you to get the initial instructions, such as register yourself or this is your C2. And they can be everywhere. For example, a social media and maybe a Twitter tag as well. And nobody will see or identify what would happen until someone actually tweets using that tag. Or it can follow up a general tag and it could seek for some certain instruction. And this has been done by tool anyway. The other type of C2 is important because we need to now communicate, not in real time maybe, but we need to push out some data for the implant. So implant will run it and will send some issues or maybe some tasks or maybe loot as well. In this case, it is important to understand what implant can do, but also to understand what we want to do through this protocol. Based on those requirements, we can use HTTP or HTTP WebSocket, DNS or similar protocols. And it is called tasking and task management. Another type of C2 protocol is payload servers. And they are there to deploy additional stages. If you want to deploy your second, third stage malware or some dangerous binaries through your C2, probably you will burn your C2. Therefore, we use also payload servers. And the payload server serves some additional stages for the implants, such as some DLLs, some shellcode, or etc. But they need to be also encrypted. In some cases, we see all of them combined, and some advanced, adversaries, we see them distributed to different Docker containers, different servers, or maybe already compromised components or companies. Now, if we want to build an implant, we need to start with some gadgets. Something must be there already. And this can be actually a gadget list or pre-used code. MSDN is quite helpful, and I use MSDN to build Windows API code or some simple instructions. But also there are really good researchers in the wild, and their repositories are quite impressive. If their license allows, and if you show your respect to those authors and researchers, you can use their samples in your implant to work out. And if you have improvements, please share with those researchers to improve their work as well. For this perspective, we generally focus on the gadgets. What we can use, can we make it a function? Can we implement this in our implant, in our malware? Okay? So there are several examples out there in Atomic Red Team repositories or individual researcher repositories. Now, registry. It is one common feature we need. Registry is important because we need to add some registry keys or remove some for different purposes. Persistency is one of those. But there are also privilege escalation, COM hijacking, lateral movement techniques. They are there and they involve some registry operations. To do that, we need to understand how registry works. That's why registry basis dictionary in this example shows you what registry keys could be used in hierarchy and how we can create one or how we can work with that. And whenever we learn how to create, how to delete, how to work on the registry keys or the values, that will help us to build our implant's additional capabilities. So we need to make this a standalone class or an integrated class or maybe a third-party feature. Whenever necessary, we can load this from remote. But it is used for several different purposes. So we need to implement this part. Another one is also the process. It is important to understand how the process things work because we need to run some commands. As an implant, we can simply run some commands such as whoami, calc, and etc. or notepad, and they can be used for, let's say, open book exercises to generate some indicators of compromise. But if we need to go subtle, we need to use some additional features here, such as changing the startup parameters and working on the process components. But this really helps us to run some commands in this environment. We can make it a single liner, or we can make it a bit custom. That helps us to give some parameters and commands as well. One another requirement is the encryption. As our implant will retrieve some data from the victim to our server, it is important to hide this data in the cloud environments and in secure networks. We don't want to reveal the data without any intention. Another problem there is we will need to use encryption to hide hide our malicious activities. Some of our malicious activities will be in the source code itself, for example, hiding a kind of shellcode. Or some of those will be on the network, such as RCT communication. So encryption helps us to harness this layer and make it non-readable or not easy to decode or not easy to decrypt. The problem there is what encryption type we use. Because if we use symmetrical encryption, our implant will need a key hard-coded, or during session we need to push it out. That will reveal the key, and that will be actually leading to full compromise and full decode of the implant. Instead of this, we can always use public key, private key encryption. So it is a kind of choice for you, and this is easier implementation of the symmetrical encryption. So you can use this with the keys, and keys can be generated per session when the client arrives, when the client connects. So this will give you at least an option to keep the key in memory, instead of hard-coded in the client, in the implant itself. Another one is also we need to retrieve this instruction list or the content from remote. That's why we use some web client or WebSockets or similar features. The problem there is we don't know what we will retrieve. That's why we need to handle this very carefully. We use socket.net features. In this case, and socket.net will have web client for us. When we create a web client, it will give us some features such as proxy options, such as cached credentials. So we can assume that the user already had credentials before us, before we arrive, and we can start using it. That means we don't need authentication. That would make things easier. But for this simple implementation, creating a new web client will suffice. And from that moment, you can just assume that, just like your interactive menu, you can use web client to get a file from remote and use your own switch case to create a branch, or maybe multiple branches, it's up to you. In this case, web client may support multiple functions for you, multiple methods. One of those is download data, and the second one is download string. We use those two too often because download data gets everything in the byte array, and download string will give everything in the string format. We use download data because it is less monitored or less understood as it is byte array. So we can get this byte array and we can process it. If you get the assembly as string and try to parse it and also run it, that will not work. Instead, get this as a byte data and try to process this and then load this assembly. Of course, loading assembly will require another function for you that we will discuss shortly. But if you want to enrich your web client, there is also an advanced feature for it. So we can always use web request instead of web client. Web request will give you multiple options. For example, communicate through the headers only. That is useful for the cloud environments. If you want to deploy your C2 as a serverless application to the cloud services, you would prefer to use some certain headers. For example, AWS, Azure, or Google headers in your communication to make it, not easy to understand or not easy to spot. And you can base 64 encode the content or maybe just encrypt the content for this purpose. Another type of requirement here is actually to understand the flow itself. That's why sometimes you need to use also the response and stream, because download data and download string will give the data like this. But when you start dealing with the web request, you don't know how to deal with the data, because data will be even a stream. So you need to make it a stream, you need to handle the data properly to not lose any content on the way. As I mentioned that you can get a kind of binary from remote, but you need to run it, right? That's why you use system reflection assembly. Just like in the PowerShell, because it is also a .NET feature available on PowerShell as well as .NET as well as C#. So you can still use system reflection class for this feature, and you can use load method to load an assembly from remote or local, whatever you do. But I made this function for an easy access, because whenever you give a byte array, it will load this and run with the parameters there. But you can make the parameters also a variable, and you can put this in the function there as well. But this is a kind of homework for you. You can easily copy and paste it there, and you can look for any parameters or any arguments given to run, because you can pass it through. It's up to you. Also, there is another option here. In .NET Core, there is Roslyn, and in .NET Framework, we have actually a C# code provided for the .NET Compile features. That means we can compile C# code or simply .NET source code in memory, with providing no artifacts, no files, no executables, only in memory as a kind of variable or a kind of data for us. Roslyn or C# code provider will work for us, but it really depends on what .NET version you use and on which platform, because it is not good for all platforms and it doesn't work exactly as expected. In this case, the provided example is for .NET Framework, so you can use this on Windows .NET Framework environment to compile the given C# in memory and make it an assembly and load this and run it. The lines are explained in the comments anyway, so that's a good one. So it is your exercise time. I will give you another hint here, but this time hint will be extended, because I don't know where you want to go, but I have different options for you. The option one is you can download a simple text file and understand that, okay, there's a content here, let's say C2 instructions given by a server, how can I run it? Or you can actually go one step further and say that, okay, these are the instructions, can I load anything else from remote, any new modules or something like that. And one more, let's make it, for example, download a text file, discover C2, download stages, and start beginning and run interactive in real time, implant and C2. So the problem there is how you can fit everything in, let's say, 15 minutes. That's not always possible. So I will assist you and show some code segments and gadgets I have put in your chapter 2 folder. So let's start with that. Firstly, this is our environment and we see the chapter 2 here. The chapter 2 has multiple examples for us, and some of those are highly important. And let's start with the simple ones. For example, the process check is a class, and it has a method there, it is a function, and it is each process running. So if you want to move this class to your code, you can easily access this using process check .is process open and explorer, and it will find explorer if there is a process like that. So it will help you to understand what process is running. Another one is web client. You will need to download something from remote, right? That's your example. It accepts some arguments, but the arguments must be in an order. The console right line help actually shows you the options. For example, URL, ASM source, and file, ASM file source. So simply you need to create a web client if you want to deal with the remote, because the instructions and the content will be coming from remote. And you need to also create some variables for byte data, which would be assembly, or source code, which could be string. And you need to parse the instruction. If instruction is URL, that means you need web client and get this from remote. If it matches with ASM, you should expect a kind of assembly coming. That's why you need to use byte array and download data. And your function exec.NET assembly, as I already shown you, It is there to parse this. If it is .NET source code, you can use .NET actually download string for web client. But it can be also a kind of binary download data, and you can convert this using encoding as well. But that's an option. File also shows you another option, and reading a file or reading your content, writing your content. So you now know that there's a kind of class for you for the file I/O options. So simply you have these options, but you need also those functions in your code in the same namespace. So in this case, compile.NET source, the function I have shown you, is here to compile and run the C#.NET source code. Of course, references will be a kind of trouble, so you need to adjust the references, and you should make it a kind of array as well. It is same for exec.NET assembly. So it is up to you how to improve those, but it will work for the simple examples. One more thing is important, because our normal client will retrieve something and start working on it. What if we want real-time communication? That's our reason for WebSocket implant. And this WebSocket implant is quite simple. It creates a WebSocket client this time, and it tries to connect a certain service given. And if the WebSocket is open, it receives the instruction, it processes the instruction, and after that, it actually sends the data as a result. That's actually a kind of pipe. That means the server side needs a kind of menu to give this data, implant needs to run this and send this back. So we need a kind of communication like this. The instruction process on the implant is the function we actually use. It is the interactive menu you were looking for. So you can put actually everything there, and the instruction process will help you to do that. The question is, where can you find a kind of WebSocket server? That is there actually in the same folder. WebSocket C2 folder has program CS as well as the WebSocket service for you. That means you can create a new WebSocket, then create actually a kind of menu for the user, and wait for the clients arrive. If any client arrives, and you can start actually waiting for the input from the user. Whenever it arrives, just pass this to the client. The WebSocket service class is there for the general use, but you need to customize this for SSL certificates and some other features as well. So it is up to you. So from this moment, you have options and you can use that. So let's compile them and see how will they work. First things first, our MCS, which is the mono C# compiler, will help us to compile the web client in this case, okay? And now web client will be the web client as designed, and it actually gives us some options. For example, running some additional features and running some additional components. In this case, I'm showing you the C2 commands I have put in the repository. So there is a kind of a executable there, a .NET binary. So let's use web client exe. It simply says that URL ASM and after that the exact URI for the assembly. So let's use that. For example, mono web client URL ASM, and then that is the exact link of the executable. I'm talking about the raw link, by the way. Please don't get confused there. When we get this, it will load the assembly and it will run. The output is coming from the assembly. So we have something to start, right? So we can build something top of this. It's up to us. Another one is also important because we have some multiple options as mentioned. If you want to go to interactive path, WebSocket is a really good one to implement this. And let's start using this example. Let's start working on the WebSocket implant. The WebSocket implant, as I actually demonstrated the code itself, it is quite easy to understand. If you understand the classes are coming from .NET, not you developed. Simply, it will connect to the server, but it will require a parameter. This time, it is using WS as the URI start. But HTTP will work as well, because that is how WebSocket class of .NET works. We need to run the server in this time, and the same folder has WebSocket C2. When you enter it, and when you use .NET Run, it will actually start the WebSocket service. This means you can start listening to. The port is hard-coded, you can change this as well. Port is localhost 5001, it's up to you. And now, we are looking for this part, which is quite easy. Same URI and giving this as a parameter. And of course use mono, just not like me. And now we are connected to the C2 server. The thing is, C2 server will need to give commands and the implant needs to run them. The commands are not implemented on the server side. So the server says that yes, there is a client arrived, so I can give these commands. On the client side, we can also debug all these features. So it is easy to understand this communication. And echo a number, it will be given by the client. And run who am I, it is coming from the client as well. It is real-time communication, and whenever you hit exit, the server as well as the client, they will just stop working. You can change the words and it can be good as well, it's up to you. So this is how it works. This is how it works for different source types and different C2 and implant types. What you need to do is now enriching the switch cases and using branching in your favor. And you need some classes there and you need some code segments, and they are in the chapter 2 folder, so you can work on it and you can enrich it. Okay, I will be on the Discord of Adversary Village now, so if you have any questions, we can start working on it, and how we can go further is in that folder as well as on Discord. Thank you for your time and thank you for listening to the chapter 2 of this exercise and workshop. Hi, I hope you enjoyed your chapter 2 exercises, and I hope you already have a sort of implant working. But this time, chapter 3 will be a bit different because I don't know what type of implant you have and what type of features you're exactly working on. That's why I will talk about some techniques or capabilities that you can add top of your implant. So this will be more like a kind of instructive part. But after that, I will supply some code examples to you that you can utilize in your implant. And some of those will be coming from the Fatih implant I have mentioned in my presentation. So now let's start with the Windows API and how we deal with that. Windows API. In .NET Framework, we use Windows API through the platform invokes, which are also known as PINvokes. Platform invokes are available on Microsoft web page as well as the other web pages in a different way, because Microsoft web page actually defines how platform invokes work and supplies some information. But you need actually the platform invoke, actually the exports converted to the .NET environment. Simply, it allows us to use exports of the unmanaged code. But we need to understand what type of variables, what type of content they expect, what type of data is expected. To do that, we need to understand actually this as well as define in our code. Then we can use those functions as our internal functions, such as this. This one is a good example because it is using system runtime interop services, because this is how platform invoke works. And it is using actually user32 DLL, which is an internal Windows DLL, and it is used for Windows API as well. And it is simply using message box function. So what we see here is the first one is the extern, simply defines that export for us. Simply we are looking for an export called message box in the DLL named user32 DLL. And those are the variables and data formats we expect. So now we can add our own and we can make it working like that. It is easy if it is only message box. Platform invoke actually gives us more opportunities in different platforms. For example, if this could be a different platform such as Mac, we would use dynamic libraries just like the DLLs. So it is not so different. We can still use private static or public static external and we can just work on it. The problem there is, though, if you start developing your tools based on the APIs, Windows API or Mac or Linux, simply start using unmanaged code in your environment, it will change your code as well as programming perspective, because it will be not a part of your code. So it may not be present in the targeted environment, in the victim environment. So you need to make sure that the APIs you need are available in the target operating system. Otherwise, they will be there and they will work on Mac, Linux, and Windows. When you start referring certain libraries, things change. It is same for Linux, as you already see. It is this time libc shared object 6. So simply you try to get pid, and it works just like this. So things slightly gets complicated from this moment because we use one single DLL, one single actually export. And if we want to go in different ways, for example, the process injection, shellcode injection, DLL injection times, then we need to use multiple exports, multiple Windows APIs using the right content. If we use them improperly, probably our application will crash. And worst case, the process or the target operating system will crash. So we need to be very careful from this moment. So where can we find this information though? I mean, how we can understand what data types are accepted by the targeted export, targeted and managed DLL function. In this case, pimwork.net helps us to understand those APIs and how we can use those DLLs. But we can also create all these using their tools as well. This is another example, but this time it is going a bit complicated. Not so complicated, but still you need to follow this up. First things first, this is a shellcode injection. This is a good start. Let's focus on how we prepare our initial part, not before we need to prepare this part before using our functions. So it is important to understand what API calls we are planning to use. In this case, virtual alloc will be used to create a memory space for us. And we can create read-only, read-write, or read-execute, or read-write execute permissions in this memory space. Create thread will allow us to create a new thread, and wait for single object, we will wait for single object will allow us to actually wait for it. So let's start with that. If we try to use virtual alloc using page read-write execute permissions, it will create a memory space for us and it will return the function address. So simply, now we know that there's a memory space created for us and we have the address of the pointer of that part, so we can start using it. There are two options from this moment to pass data to that memory address. One is the Windows API. I didn't use this in the example, but it could be used. For example, write process memory. The second one is the marshalling, marshal copy. That is an internal functionality in the .NET. The difference between those two is actually evasion. We will discuss this in chapter 4, but this is a kind of simple evasion. If the EDR or antivirus expects, for example, virtual alloc, then write process memory and create remote thread is a pattern, we simply break this pattern. We don't use write process memory in this example. So this is one of the points that we can add for evasion. But this is only for functionality and use for here. And we use marshal copy to push our shellcode, the byte array, to the given function pointer. So simply we define that shellcode from the 0 and this function pointer and the length of the shellcode. So simply our data is in the memory. The problem there is we need to also create a thread pointing that part. So the thread will start and it will execute our given shellcode in that memory space. So create thread will help us to create a thread using that data. That's why we use the function address here. And then we simply create a new thread in our own process. And we wait for it. And when it starts, that's good. We have a new thread and the shellcode executed in the current running process. If the process exists, it dies. If the process has been killed, it dies as well. So this is really important to understand because it is still an inline code execution. If we go for remote process, that will be a different case. This approach would be still called slightly safe because you are still in your current process, you run code in your current process, and it is a sort of normal application behavior. When you start dealing with the remote processes, things will change and EDRs and other things will identify you. Moreover, whenever you start using Teambox and APIs like this, the EDRs will also catch you for the API perspective. Now, there is another one, but this time we are using QUser APC. And as you imagined, those functions, the APIs, also have their actually definitions before this function starts. Let's try to explain lines here. It is important to understand the base64 content here. Normally, most of the researchers or sample suppliers or proof of concept researchers, they put the shellcode in base64 format to the code or as a byte array, and it is really easy to spot by the antivirus or maybe EDR tools. But we can change this approach because static analysis is also something. And if you have the payload, that's a bad thing. Simple evasion here is just placing a random string before the base64 content, which will break the base64 and then replace it in the next line or maybe a few lines after. Simply, you will decode this, you will access the real data, but under certain conditions. You can make it conditional as well. For example, you can check the host name, you can check the cloud components, you can check the device. That will help you to understand what environment you are working in. That is also chapter 4, evasion techniques. When we deal with the other stuff, it is similar as well. For example, in this case, the process injection, the thread injection to a remote process works pretty much like this. Firstly, we use another process. But I'm not doing this to a remote process already running. We create a new process. That's the good part. And that also helps us in a couple of different ways because we can groom it. We can just use another process as its owner as well. But that's another example in your folders anyway. So you may actually spoof your current PID. You can also change a couple of things while process is suspended as well. Because you created this process, it is suspended and it is ready for any manipulations. So you know what state it is. After that, dealing with its handler and creating a new memory space there using virtual log. But this time using write process memory to push the data. You can still use partial copy, but write process memory helps here again. And get process ID. And after that, we have process ID, we have threads, we are using open thread for the thread itself, and we recover the permissions of the memory space using virtual protect this time. Because initially we used read write using virtual log, but this time we make it read executable. If we don't do that, it will fail. If we use read write execute, that will be not good for the dev perspective. So this is more accurate. After that, we use QUser APC for this thread. So simply the application will know that there is something waiting here and it will process it when it starts running. Then we resume the thread and it will work. So this is how it will work in the code perspective. So in this case, you need some of those examples. The good part here is attack capabilities class is supplied in the chapter 3-4 folders. So you can go to the attack capabilities to see those functionalities. They are actually enriched. They are actually changed. For example, they spoof the parent PID and etc. When you look at the code, you will see some improvements there. Moreover, as I mentioned, some of the .NET features allow us to pass the parameters while running the assembly itself, which is good. And you can actually see that it is implemented in that code. It is same for the actually source code compile. The exec gives you multiple options for the parameters. So it is quite useful. You can either way get this class itself as a part of you, or you can copy that function. But remember that you need the previous definitions because they are PMOX. and you can copy to your own code, one by one. Because Fatih is in the MIT license, so that's the point. You can use it as a gadget. So you can actually extract whatever functionality you need from that one. In addition, it can run the PowerShell, but the PowerShell is running through the system automation. System management automation DLL is referred as well as necessary. When you compile this, and if you enabled or if you didn't remove this PowerShell automation class, the function, you need to compile with the reference of System Management Automation DLL, which is a good example for you. I put the DLL in the same directory so you can see it. But if you target a specific framework version, it may not work. So you need to use nuggets to get the correct version of the System Management Automation DLL and then refer it. If you want to use specifically that DLL to work with your implant, then you can use actually some merging tools such as IL merge. So they will be one single binary with this DLL coming. So simply it will be a part of your functionality. And you don't need the system to have this management automation DLL. So the exercises. The exercises are slightly simple, but also complex this time. Simple because you will add one or two functionalities. I assume that you already have an implant and it can communicate with a web service using WebSockets or a web page using web client or a console application with the user. And you already added some functionalities there. When you looked at the chapter folders, you already found some of the functionalities. Now in this exercise, you need to extract some of the functionalities from Fatih and use them as a gadget. And you will understand what is missing when you try to extract that portion of code. Because the pinbox defined will be undefined in your code and the compiler will fail. Another thing is you can also add some additional functionalities that are not exactly available in the Fatih gadgets, but they are available and also introduced to you as, let's say, encrypt and decrypt in the previous chapters. And you can make them a kind of ransomware for yourself. For example, encrypt a certain file, decrypt a certain file, use a key. If you remember the encryption and how it can be used, it can be dangerous as well for the ransomware operations, right? So let's start with that. First things first, let's work on our environment and walk through our source code. This is our source code environment. So simply, this chapter 3 has examples of encryption as well as our capabilities and some pinbox. The pinbox are here for you to copy and paste and to be used directly. I also put the README here in case of you need a kind of easy copy paste for compile or to understand the functionalities. One other thing is also the shellcode here and shellcode invoke. That will help you to actually inject a shellcode to the environment. Virtual alloc, create thread, wait for single object. These are the examples, are examples previously mentioned. And this can be actually utilized like normal console applications or any other example. If you remember your hello example, hello.exe was actually running as an assembly from remote, right? If you understand that part, you can also use this shellcode invoke and it may accept the demo parameter. As you see here, it accepts parameters. And if the argument, the given parameter is demo, it runs this functionality. That means also, if we send demo, it will run this shellcode given using the exec shellcode 64 function. And this shellcode is the shellcode of calc to run in your environment. This will only work on the Windows, of course, because process injection is not designed for Mac or actually Linux. And it will require 64-bit. So this will use the function that I will explain in a couple of minutes. So if that is the case, your implant can utilize this DLL, this assembly from remote. What I suggest is compile this, make necessary modifications, upload this to a remote location, or use your Python simple HTTP server or something like that, and serve this DLL. Or you can use file IO read as well. Read all bytes in the file will help you. If that's the case, the file will be loaded. Start using your own .NET code, .NET assembly run code to run this assembly. Because this assembly will require a parameter. Make sure that this parameter is passed through. Then you can observe this example will be loaded from remote to run as well as inject the code. Now let's work on the code part. As you see, the base64 content is there and it is removed and replaced. So the static binary may have less concerns. I'm not saying zero detections, definitely. The PE executable, when you compile this, will have already some indicators because we use pinbook here. Anyway, the exec shellcode will actually accept the byte array to run this shellcode. There is also raw demo. I made actually comments here. You can uncomment this to see the detections and the components because it is the same source, actually same shellcode, same bytes, but this time it is not encoded. It is the byte array itself, so you can use it. Actually, this will be also interesting for you. So you can make it a kind of staged environment. Let's assume that you had already an implant and it was checking the C2 command text on the GitHub repository. So you can download this DLL from remote, and given parameter will not be demo. Given parameter will be another raw DLL pointing to the shellcode. So simply you have multiple stages. Your first stage is the implant itself. Implant gets the second stage, which is another .NET assembly, and given by the C2 command text. And this binary will also require the third one, which is the shellcode in base64 encoded or byte array format. See, multiple stages. If you are making it also a purple team exercise, place flags on them. For example, put some variables, change variable names, and make them a kind of flag for your blue team to identify the levels of the structure. Maybe they capture the first stager, but not the second. Or maybe they have no idea about the payload coming. You see what I mean? You can add flags and you can improve the detections and you can help your blue teamers to understand this process and stage the approach. Because if you do not ship everything in one single monolithic file, the detections will fail. So it may help them to understand where they fail. Also, this Excel shellcode function is the function I have actually shown you. So it is slightly simple. Attack capabilities, on the other hand, it is quite rich. So you can exactly see how it will work and what actually variables it uses and what pinbooks are already defined for what purpose. When you scroll down, you will start seeing the functionalities. Each function will have a different purpose. In Fatih implant, in the repository, you will understand the reasons as well as content. But in this example, this simply checks that the platform is Win or not. If it is not Windows, your implant will refuse the work or say that those functionalities are not available on Windows. Please give me other functionalities. So you can load another implant type specifically for Mac or Linux this time. It's up to you. Exec sharp assembly also now accepts arguments as well as thread support. So you can actually give the arguments. If it is not null, it will work with the parameters. And then it creates thread as well. So it will work as a new thread. It is similar for exec sharp code. And this time sharp code will be slightly enriched. But there is still room to improve this because as you see, the references are hard-coded. So you can actually create another array here or a list to add more references. So if someone pushes sharp code, a kind of C# code to be compiled, they can also pass a list of references already required for this compile operation. I'm scrolling down and there's also exec here. And exec, as mentioned, it's a kind of process execution for us. So we can give some parameters to run this executable. PowerShell automation is there to actually run this PowerShell through the system automation. So it will use system automation if you assign it, if you refer it. And exec shellcode will run the QUser APC shellcode injection. So the content is here. You can modify it or copy and paste. Whenever you deal with the Windows APIs though, like this, you need to make sure that you also copy the definitions we already put before the code. Now, one more thing before leaving this fun. There is also ransoblin, and ransoblin is available here. Ransoblin is a ransomware vocabulary. Simply, I have used this in the TA505 exercise. So it helps me to encrypt the file and decode it as well, or decrypt it as well. And it can help you to add some ransomware functionalities. As you already see, it has a menu that we already created normally using switch. And if it says encrypt, it encrypts. If it is decrypt, it decrypts. That's it. But it is using hard-coded keys. So it's up to you to give the key or change the content so you can make it actually a good tool, right? It is right here, the key strings. Now, one more thing we have, which is our repositories that we can actually improve things. As mentioned, there are several different types of functionalities, codes, and methods here. So TA505 plus Adversary Simulation Pack also have all of those. It has documentations and it has actually resources there as well. The resources are developed for this exercise, the Excel file and initial dropper and some other contents, as well as some preparation commands, shellcode. You can use them. But more important one is it comes with the videos. If you're concerned that where we can find the videos, in the same repository, exercise videos linked here, and when you go, you will see lots of different videos here. And they will help you for each stage of this exercise, design or replicating the exercise content. Weaponization phase is related to your development. And after that, delivery and lateral movement will be related to the other sections you are planning to run. One final thing, if you want to enrich your malware, Attack C2 is here. It is also MIT licensed, so you can easily modify or copy code from there and go further. Now, chapter 3 is done, and you can use those codes in your chapter 3 folder to add additional functionalities to your implant. I don't know what you want to add, so you have multiple options here. Feel free to copy and paste them or add them based on your own requirements. I hope this works for you, and this is end of chapter 3. In chapter 4, we will discuss about evasion tactics and some of the advanced content. But this time, instead of exercises, we will try to understand how researchers designed this and worked. Thank you for your time for the chapter 3, and see you in chapter 4. And I'm on Discord, by the way. If you have any questions, feel free to jump to Discord and ask questions. If I have any mistakes with the information or if I misinterpreted some of them, please also remind me the correct information so everyone will fix this as well. Cheers. Welcome back. This is chapter 4, the final version. We will talk about evasion. I hope now you have an implant working well with a C2 or a website with some functionalities. Now it is our turn to make it evasive, and we will talk about evasion now. First things first, we have simple security measures that can be implemented to avoid this type of detections as well as security control interception. That's why we talk about a couple of basics first. Staging. As I previously mentioned, you can actually split things out. The first thing is loader. The second will be stage 1, and after that stage 2, stage 3. Whenever you split things up, that will help you to actually focus on different components. Moreover, they will work together. It will help you to implement flags and features for the blue teamers. And finally, it will avoid detections because most of the software and security controls, they focus on everything in the same place. But you can actually use a loader checking the environment. If everything is alright, it can move on. If it is not, it can stop. This is not my target. Or you can implement another check. For example, I don't want to be actually a part of this environment. Can I escape? Or you can add another check. For example, is there any antivirus or a certain process running? If so, is it my process? Or is there any MC, for example? If there is MC, you can retrieve the MC bypass tool, and it can bypass it. Then you can start loading things. But if there is no MC, you don't need to load anything from remote. So you won't expose your code. So simply staging helps you to split everything to different components. And actually it is easier to maintain, easier to deploy to the remote systems. Also, deployment part would be a problem. If you remember, the chapter 2 and chapter 3 required you to download DLLs, executables, or some C# source code from a remote web service. The real life does not like this. Real life has some proxy controls, the content filters, as well as the network directions. This means you need to change them. Base64 encoding, XOR encryption, or whatever encryption you want to add, they will help you to convert the content to a non-readable format. You can add a garbage data before base64 to break it. You can hide your content inside an image file. You can do a lot of different things to hide your data, because on the network they will be visible if you don't implement any encryption or encoding feature. This is same for the C2 communications, so you need to add also similar things to your C2 communications. Instead of a direct communication channel, you can implement actually encrypted channel. You have encrypt and decrypt functions. Add them to your implant and send encrypted and decrypted data. So the network interception will not work. Even though that will be an interception, it will not work with your system either. So it's a way. Another one is you may run in a restricted environment. That could be a sandbox, cloud, or maybe an environment restriction. So that will be because of reverse engineering or dynamic analysis or similar things. So it's a kind of defensive security measure. What you need to do is implement some security checks there. For example, check the device IDs, check the device name, and try to understand that environment is virtual or real or fake. Then you can move on. And sometimes you need to even actually define the target and try to detect the target there. For example, this IP is in scope or not. This was used by also a Nobelium in the SolarWinds exercise and campaign. So bypassing MC will be another phase, because now you know that you escaped from the dynamic analysis environment, you are in memory, and you can still load some objects from remote. That's the good part for you, and you're at a good stage. However, the MC, as well as Windows Defender, is on your shoulder. So what you need to do is actually patch it. And you can work on a couple of patches, and this example is based on MC scan buffer. MC scan buffer is actually discovered by CyberArk, and also a good .NET example is supplied by Daniel Duggan, also known as Restamouse. So his code is good. Simply, if you are patching that memory space, also it is necessary for us to say simple things to MC. it is looking for the length of the memory space. We simply say that 0. Look at only the beginning, not the main. So the implementation here is actually slightly simple. We actually load the MCDLL. It is already there. We try to get the actually memory space, actually the function pointer for the MCScan buffer. And then we simply create a new one or work on the memory. It depends on what we do. MC has tampering protection, so whenever you try to deal with the memory address directly, it stops you. But if you create a new memory space, push your actually data there, and then move the pointer, that will work. That's how it worked for Daniel Duggan's case as well. So move memory address was the solution for it. However, this patch is also detected because of the simple strings. That's why the strings are also split up to different portions to avoid detection. But it is still detected. So I have another example in your chapter 4 repository, and it worked for me in the TA505+. I simply replaced the Marshall copy with the write process memory API. And I also used handle to my own process, and it's a different function. So I used some obfuscation in your meaning, and it worked. So you may have a different point of view there, and you can add more functionalities to make it work. Bypassing event tracing for Windows is also important for .NET, because event tracing for Windows is developed for debugging and performance monitoring for the applications. However, in .NET environment, it gives a lot of information about our .NET assemblies. To avoid this type of stuff, we can actually take some precautions. Changing some environment variables, patching our binary, and focusing on ETW content, that will really help us to change our detections. Even obfuscation will work. For example, some of the tools check out the name of the tool we use. For example, seatbelt or ghost pack tools. They are identified very fast because of their names. So you need to obfuscate them. That we will discuss shortly. Silk ETW from Ruben Boonen. It's a really good tool, proof of concept tool developed for ETW, and saying that ETW can be used to detect actually .NET binaries and applications and malicious code and tradecraft. Simply, most of the EDRs started actually adding this feature to their products. So it can be changed here. So whatever you do for ETW, you need to somehow evade this. Otherwise, even proof of concept tools will understand you, but now it is also EDRs monitoring you as well. These are the blogs coming from different researchers. They explain how they have solved this problem. Dynamic invoke is also important. It is again coming from Ruben Boonen and Vova. So simply, we have some issues with platform invokes, and this research is the solution for it. Whenever we use platform invoke, we actually reveal our intent, and the imports of the PE binary also includes those APIs we try to add. That means even during the static analysis, we reveal our intent. And it simply says that these are the APIs this PE binary wants to use. To solve this problem, we can actually resolve them in memory. This has been a solution for the C or assembly unmanaged binaries. However, in our C# world, we don't have these type of functionalities. On the other hand, Ruben and the Vova have solved this problem partially, and they focused on dynamic resolution. So simply, they are offering that why we are not resolving the same APIs in memory. But it comes with a cost as well, of course. It focuses on delegation and the function pointers. You can read the research, try to understand this and its background. Or the other option, if you don't like to understand everything, you can use the nugget prepared by the Vova to implement this as well. It is also a part of Sharpsploit, which is a lot of functionalities packed in ADLL. All PowerSploit features as well as newly added features are packed Sharp-exploit DLL. So you can use this DLL as a part of your implant, and you can start invoking all these APIs using this type of dynamic resolution. So it relies on the delegate pointer now. On the other hand, .NET can also run some unsafe code for you. That means you can run unmanaged code here, but it will be highly sensitive as well as fragile. So simply it can be broken and very platform specific. You simply hard code things there. So you need to be very careful about what exactly you are doing. However, .NET supports this. If you compile the application using the unsafe parameter, it will allow you to run this type of stuff. But again, it depends on what you want to do. There are examples here again, Jake Hallen and Bed Bounty. So simply you can see how it works for you. And if you want to add more assembly instructions there, for example, dynamic resolving of PEB, so process environment block, and then work on kernel 32 and finding it, and then dynamically resolving the rest using get process 32, and then load library and move on and move on and move on. Running unmanaged code in .NET is also possible if you actually escape from this sandbox. Simply, .NET is a managed environment. And if you want to go to unmanaged environment, you need pointers and delegations. Simply you need to escape. Adam Chester is a really good researcher, and he found a couple of different ways that helps us to actually escape from the .NET managed code to unmanaged environment. It is using actually method desk and pointers for the function pointers, and it is very similar to dynamic invoke and get delegate for function pointer. So simply Marshall get delegate for function pointer has been used to dynamically resolve the APIs in the invoke research, but this time we simply used other delegations, intercall and qcall, to escape from the managed environment to unmanaged. Obfuscation is also required because whenever we use .NET, we also know that this is bytecode, and bytecode can be easily converted. So it comes with a cost, which means there is nothing to hide. Actually, this is a good thing for us because it makes things easier, but it is also a bad thing for our activities. If we are developing Adversary Tradecraft for red team operations, we need to go subtle, and we should not reveal our intent. And in that case, we need to also change our point of view. There are options for us to actually convert our code to non-readable format, but also keeping the code as is, so code will work, but also not easy to read. We call this as obfuscation. Obfuscation can be implemented in different layers. For example, randomizing strings or adding some functionalities, or maybe the performance optimizations can be rolled back. Simply the compiler performs some operations to actually simplify your code. That's why the performance optimizations happen while compiling the binaries. In this case, you can actually use similar functions, some unnecessary calculations, or you can make the names as calculations as well. This will help you. If you don't want to do that manually, which is understandable, it's a kind of long and accurate process, there are some tools that help you to obfuscate your .NET applications. Confuser X or Obfuscator or similar tools such as for PowerShell Chimera would help you to add some obfuscation techniques. For example, offensive pipeline would be used to compile some open source .NET projects, the Tradecraft, and obfuscate them and then compile and push out. So it will help you to actually automate some of your tool and Tradecraft management. If you implement this with your implant as well as C2, that will give you more flexibilities. For example, the implant will actually connect to the C2, start communicating. Whenever it is necessary, the C2 will compile the public tool, for example, GhostPack tools by Spectros, and they can be supplied as a dynamic content. So it's up to you, and it's up to how complex your implant. Of course, there are some general suggestions here as well. Because it is a kind of adversary environment, we need to slightly simulate them, right? So they need to be approximation or maybe one-to-one emulation. So it is really up to us how we should follow this path. Getting a kind of signing certificate, some of those already exposed in the wild, stealing or reusing some of those in our binaries, making it legitimate one is a kind of option. Or implementing a kind of driver, that will be another case for us. We can deliver some of the content using the WebDAV, and we can actually deliver the content inside stages using WebDAV as well. And there are some C# WebDAV implementations that you can use. If not, you can still always use some other binaries or Python files that can be compiled for Windows. Legitimate binaries are also important because I can give you a lot of heads ups there, and the exercise will get longer and longer and the workshop would not end. But LOL means living off the land binaries will help you to load your .NET applications. So there are several different ways to sideload your .NET application to legitimate binaries. That includes MS build, install util, but there are also some other .NET binaries can be actually loading your binary using only the configs that you can add in the same folder. So it's another research for you as a kind of homework. Other things are also common. For example, common hijacking. Com hijacking, sorry. Com hijacking is also a kind of common vector for the persistency and lateral movement. We discussed about this a bit actually during the registry manipulations. So com hijacking will allow you to influence the other processes and other applications and their execution style. Simply, you can create some registry keys in your current user environment as they will be available in the HK root. The applications will find the CLS ID you created and it will actually run the commands you have given. Those are quite useful tactics if you want to run your loader without a relationship to the starter, for example, Excel files. MC is important. You need to deal with MC. As mentioned, you can actually patch it, or you can just unhook it, or you can dynamically resolve your APIs. It's really up to you. I didn't talk about EDR unhooking techniques here, but they can be still useful in .NET environment if you want to go to unhooking environment. So .NET is a good environment and it can provide some of those, but not all, of course. There is no kernel driver in C# as far as I know. But it can also help you to create some other tools in this environment as well. This means your Tradecraft will be enriched using .NET, but if .NET is not your favorite, please use the other language, whatever you prefer, to reach out this type of data. I supplied some examples in your chapter 4 folder to actually work on all these. So using this information, now you can actually make your implant working with advanced features, implement different types of injections in your implant, and actually add some evasions. For example, your APIs will be dynamically resolved, or you can get the shellcode from remote with some encryption. You can check some sandbox, you can check your target. Those are good things, and if you implement them and make them simple classes, that will be really good for the environment. Or you can make them small assemblies called gadgets, and you can call it from remote. And your initial loader will not have those functionalities, and it will try to get, for example, the remote gadget of check windows or check target assembly. It's coming from remote. If Sandbox doesn't have any remote connection, it will fail and you are safe anyway. Dynamic analysis will not work. If you get this from remote, for example, an online sandbox, that is also possible, and you can check Windows. And your cloud check will be coming from cloud and internet as well. This has a cost though. If the client has no internet connection, your implant will not work. So it's a kind of trade-off, and you can just work on this type of stuff. Conclusion. So we had a large set of exercises today, and you try to build your implant, you try to enrich your capabilities, you try to implement this using a C2 and try to add some evasion tactics here as well. So they are good things, but you need also homework. So you are looking for next steps. These are my suggested next steps for you. There are some C2s and implants developed in C# in the wild, and they are developed by really great guys. And I suggest to follow these guys on Twitter, visit their GitHub repositories, and try to use their tools and understand their techniques, such as Adam Chester, Dale Duggan, Ryan Cobb, and they are there, and they generate a lot of different content for .NET as well as Adversary environments, so they can be useful. And thank you for your time and joining me in this workshop. The next phase for chapter 4 is your homework. So feel free to take your time, understand this, rewatch the exercises as well as all this presentation. Try to understand how it works and what you missed. And after that, we can just make it better as well. I will take questions through the Discord of Adversary Village. So simply please place your questions through the Adversary Village Discord channel. I will be online, even though this recording will help you, serve you for online purposes. And thank you for your time. Thank you for joining me. I will wait for your questions.